Hi students, today we are going to see the session 7, Lagrange's linear type. An equation of the form capital P small p plus capital Q small q is equal to capital R, where capital P, Q, R are the function of x, y, z is called as Lagrange's linear equation. To solve this type of equation, consider the auxiliary equation as dx by capital P is equal to dy by capital Q is equal to dz by capital R. Solving this Lagrange's linear equation, we have the two methods. One is a method of grouping, another one is a method of multiplier. So first we are going to see the method of grouping. So in a method of grouping, the auxiliary equation is dx by capital P is equal to dy by capital Q is equal to dz by capital R. If the variables can be separated in any pair of equation, then we get the solution of the form u of x comma y is equal to a and v of x comma y is equal to b. Now we go to the problem. Solve the equation P tan x plus Q tan y is equal to tan z. So take this a given equation P tan x plus Q tan y is equal to tan z. So this is how the form capital P small p plus capital Q small q is equal to R. So comparing these two equations, so identify what is it capital P. Capital P is equal to tan x, capital Q is equal to tan y, then capital R is equal to tan z. So now we are going to write the subsidiary equation as dx by tan x equal to dy by tan y equal to dz by tan z. So now from these three terms, we can consider any two term, that is combine the either you can combine first and second or first and third. So now I consider the first and second term dx by tan x equal to dy by tan y. So now we can write this 1 by tan x as cot x. Then here 1 by tan y as cot y. So now we have to integrating on the both the sides. So integration of cot x is sin x. Then integration of cot y is log sin y. Plus integration constant have to write the log c. Then bring the log sin y to this side. Log sin x minus log sin y equal to log c. Log a minus log b. This is the form log a minus log b. Log a minus log b can be written as log of a by b. So a is equal to sin x, b is equal to sin y. So which is equal to log c. Both the sides log is having. So we can cancel the log. So therefore take the another constant c1. c1 is equal to sin x by sin y. The solution we can write u of x comma y is equal to sin x by sin y. So this is the one of the solution. Then another solution we have to consider the second and third. So consider dy by tan y is equal to dz by tan z. So this can be written as cot y dy, cot z dz. After integrating, we get the log of sin y by sin z is equal to log c. Then log sin y by sin z is equal to c2. Then v of x comma y is equal to sin y by sin z. Therefore, the solution can be written as pi of u comma v is equal to 0. So we already find out the u value sin x by sin y. Here right, then v is equal to sin y by sin z, substitute here. So finally this is a solution for the given linear partial differential equation. So next we go to the another problem. Identify the appropriate method and solve x into y minus z into p plus y into z minus x into q is equal to z into x minus y. So from this equation you have to identify what is the capital P. Capital P is equal to x into y minus z. Capital Q is equal to y into z minus x. And capital R is equal to z into x minus y. So now write the subsidiary equation dx by x into y minus z equal to dy by y into z minus x equal to dz by z into x minus y. So here we can't combine the any two terms because here we can't directly cancel any term. So directly we can't integrate. So therefore we have to add the numerator separately, denominator separately. If you add the numerator dx plus dy plus dz by here multiply xy minus xz, yz minus xy, zx minus zy. So plus xy minus xy cancel, minus xz plus xz cancel, plus yz minus yz cancel. Therefore dx plus dy plus dz is equal to 0. So after integrating, we get the x plus y plus z is equal to integration constant. So this we have to take it as u of x comma y is equal to x plus y plus z. Next another one consider as 1 by x dx. That is take this x to the numerator. So 1 by x into dx, 1 by y into dy, 1 by z into dz. Then add the numerator 1 by x dx plus 1 by y dy plus 1 by z dz. Divide by the denominator if you add y minus z plus z minus x plus x minus y. So here also plus y minus y cancel, plus z minus z cancel, minus x plus x cancel. So remaining 1 by x dx plus 1 by y dy plus 1 by z dz. So now integrating this one, integration of dx by x is log x. Integration of dy by y is log y. Integration of dz by z is log z equal to integration constant log c. So this is the form log a plus log b plus log c. So log a plus log b plus log c can be written as log abc. So log xyz equal to log c. So both the side we can cancel the log. Remaining will get xyz is equal to c1. So this one we take v of x comma y is equal to xyz. So we got the u and v value. Therefore the solution is uh, pi of x plus y plus z comma xyz is equal to 0. So next we go into the method of multipliers. Choose any three multipliers L comma m comma n which may be a constants or the functions of x, y, z such that dz by capital P is equal to dy by capital Q is equal to dz by capital R, which is equal to ldx plus mdy plus ndz by lp plus mq plus nr. It is possible to choose L comma m comma n such that lp plus mq plus nr equal to 0. Then the numerator is also ldx plus mdy plus ndz is equal to 0. So this numerator will give the exact differential. Then integrating we get the solution u is equal to a. The multipliers L, M, N are called the Lagrangian multipliers. So in this method we have to choose the multiplier according to the denominator become 0. Now we could go to the problem. Using Lagrange's method, solve the partial differential equation x into z square minus y square into p plus y into x square minus yz square into q, which is equal to z into y square minus x square. So from this identify what is the capital P. Capital P is equal to the coefficient of small p. Capital Q is equal to coefficient of small q. Then capital R is equal to the right hand side value. Then we have to write the subsidiary equation dx by x into z square minus y square dy by y into x square minus z square equal to dz by z into y square minus x square. So now we have to choose a multiplier as x, y, z. So if you choose a multiplier x, y, z, so that multiplier have to multiply numerator as well as denominator. So x dx. Then here denominator will get the x square z square minus x square y square. Then plus. Here choose a multiplier as y. So y dy by y square x square minus y square z square. Then next here choose a multiplier as z. So z dz by z square y square minus z square x square. So here x square z square cancel. X square y square y square cancel. Then y square z square cancel. So the denominator equal to 0. Here we have to equate with some other constant. So remain only have to take the numerator x dx plus y dy plus z dz equal to 0. So now integrating this one. So integration of x dx is x square by 2 plus this one y square by 2 plus this one z square by 2 equal to some constant c. Then this one take it as u of x comma y is equal to x square by 2 plus y square by 2 plus z square by 2. So next another multiplier you have to choose as 1 by x, 1 by y and 1 by z as a multiplier. If you choose a 1 by x as multiplier, so denominator this x will cancel. Here the denominator y will cancel. Here the denominator z will cancel. So only numerator we have 1 by x dx plus 1 by y dy plus 1 by z dz. Denominator add directly. Z square minus y square plus x square minus z square plus y square minus x square. Here all the terms will cancel. Then only take the numerator dx by x plus dy by y plus dz by z equal to 0. The integration of dx by x is log x, then plus log y plus log z equal to log c. So this already I explained. Log a plus log b plus log c can be written as log abc equal to log c. Here cancel the log. Therefore x y z is equal to c1. So this you consider as v of x comma y is equal to x y z. Therefore the solution is pi of x square by 2 plus y square by 2 plus z square by 2 comma this x y z is equal to 0. Over.